Hello, seventh grade. Hope you guys are doing well. We're starting a probability chapter here, and I couldn't find a good video for this one, so I'm going to make my own. What I'm going to do is just go through the odds. This is for page 437. We're going to do 1 through 20 on this for Monday. Some of these lessons can be kind of challenging, and I'm afraid to leave you guys to your own devices. So we're going to try these odds together. Hopefully you guys kind of get it. Hopefully you guys did okay on last week's, the last assignment from last week. If you didn't, I think I'm going to put an optional assignment on Friday to redo it if you think you did it wrong. And if you want to do that, I'll give you full credit for that. Okay, so today we're going to start with factorials. That would be read as 5 factorial, exclamation mark, because it's so exciting. Okay, factorials means, all 5 factorial means is you start with 5 and you just do times 4 times 3 times 2 times 1. Okay, that's what 5 factorial means. Pretty simple, really. By the way, does times 1 do anything? No. So that's kind of just thrown in there. But it doesn't go down to times 0, right? Because that would just make it 0. But anyway, so 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 1 doesn't do anything. So 5 factorial is 120. Well, what the heck are we doing this for? This would be probability and statistics we use all the time. It helps us find like stats in sports and like your insurance, fun things like your insurance rates and stuff like that. This particular 5 factorial would be like if I have 5 kids in the class and you guys are lining up to leave, this is how many possible ways I could line you up. 120. A lot, right? So these numbers get really huge really quickly. So if I took, I don't know, there's like 17 of you. If I took all 17 of you and lined you up in every possible way, that would be 17 factorial. And I don't have a calculator on me right now, but that would be a gigantic, probably doesn't fit on your calculator. Probably your calculator would probably write it in scientific notation, that weird notation we talked about a long time ago, because this number is so huge. So numbers get really big really fast when you're talking about probabilities. So just 5 kids have 120 different ways of lining up. Okay, kind of surprising, right? So factorial, so that's how we're going to do 1 through 8. So I'm going to just go through 1 through 8 really quickly here. That's kind of the easy part. The second part's really not that hard, but you do need a little bit of teaching to be able to do that. So on number 1, it says 1 factorial. Okay, that equals 1, the end. Okay, so it's 1 times nothing else, so it's just 1. So that's a weird one. I don't know why they threw that in there, but okay, it doesn't do anything. So number 1 is just 1. Number 3, 4 factorial. That would be 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. You guys see how this goes? Pretty simple. Number 5 says 7 factorial. Oh, it's getting big. Might actually have to do some work here. I'm going to show you a trick on number 7. That can help you with the evens. Okay, so this would be 7 times 6 times 5 times 4 times 2 times 1. Okay, does order multiplication matter? No. So I can multiply whatever I want to. I think it's going to be a little bit easier to go this way. Or here, let me do this. 5 times 4 is 20 times 3 is 60 times 2 is 120. Kind of did that earlier. Times 6, that would be 720. Times 7, it's getting big. Okay, 5,040. Okay, so it doesn't matter what order you multiply it together, you should get 5040 no matter what. Okay, now let me show you a trick to make 7 easier. You can use this trick on the evens. 7 is just 8 factorial. All right, so you notice inside 8 factorial, there is 7 factorial, which we just found was 5040. And because order of multiplication doesn't matter, we can kind of just fast forward to the answer. So 7 times blah, 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 all this is just 5040. So really we just need to take 5040 times 8. And then that would give us so it's 40,300 and, oop, there you go, 40,320. Okay, it's getting very big. So this is lining 8 kids up in no particular, now it doesn't have to be lining kids up. It could be, I think one of the examples I use is putting books on a shelf. So if I put 8 books on a shelf, there's over 40,000 ways that I could organize those books. A lot, okay? That's a lot. I probably should have mentioned this earlier. We didn't need to know it yet, but 0 factorial is worth 1. Okay, there's a reason they kind of just say that's how it is. We'll find that out here in a minute. But okay, that's it for 1 through 8. Any questions? Great. All right. Okay, the second part of the lesson, we need to talk about something called permutations. And it's a big word. Permutation is where you want to find out how many possible ways can we make something happen, and it's when the order matters. There's something else called a combination, where the order doesn't matter, but we're just talking about when the order matters. So if I line 7 kids up out of 7 in the class and the order doesn't matter, there's one way to do that. But if the order does matter, there's thousands of ways to do that. So it's a big difference. So a permutation. So let me give you a couple examples. You'll see how this works. So back to that lining kids up again. If I lined 7 kids, there were 7 kids in the class, and I lined all 7 of them up, how many ways could we do that? Okay, this is how I would write the permutation. 7 in the class, I'm lining all 7 up. Okay, how many ways could that happen? All right, another example is, okay, what if there's 7 kids in the class, but I only line up 5? How many different ways could that happen? So you could say like 7, but I'm only choosing 5. Okay, that's how you would write that one. What if there's, I don't know, I have 20 books in my library, and on the top shelf I'm going to put 10. How many? So that would be, maybe writing my numbers a little bit big, but the numbers are supposed to be kind of small compared to the P. But out of 20, I'm choosing 10. So that's what that would look like. That's now what we need to talk about is how to actually work this out. So this was 7 kids in the class. All 7 of them are lining up. There is a formula. In your book, they wrote the formula towards the bottom of page 436. They put it in a box. And kind of the important part is, actually, I'm going to write the whole thing. Okay. Okay, so n is how many things are in the set, and r is how many we're choosing. Remember from earlier? And the way that you figure out how many possible ways that could work out is you do n factorial over n minus r factorial. So let me go back to my first example of there's 7 kids in the class, I'm lining all 7 up. So 7, I'm choosing all 7. So n factorial, n is like the first number, how many in the total group? So that'll be 7 factorial. And then the bottom number is, you do the total group minus how many you're choosing. So it would be 7 minus 7, which is 0 factorial. Okay, that's why I mentioned this earlier. 0 factorial is just worth 1. And when you divide by 1, that means it does nothing, right? So really, if I'm lining all 7 kids up out of 7, it's just 7 factorial, which is kind of what I talked about when we started the lesson. So if you're doing 7 out of 7, it's just basically it's 7 factorial. Okay, where it gets a little messier is when you don't line all the kids up, or you don't use all the books from your collection. You just do part of it. It gets a little bit messier. So let's do I don't want a huge number. Let's do, out of 7 kids in the class, I'm only going to line up 5. So the top is going to be 7 factorial again. It's how many are in the total group. The bottom is going to be 7 minus 5 factorial. So what's 7 minus 5 is just 2. So the top is 7 factorial, so it looks like that. By the way, we did a lot of this work on the 1 through 8. Like 7 factorial is numbers 5. So we could use that info to help us figure this out. The bottom is 7 minus 5, 2 factorial. So it's just 2 times 1, which is just 2. So I know there's 2 ways we could do this. I could take the answer that we got from 5 for 7 factorial, which was 5,040, and just divide by 2. 2 times 1 is 2. So just take the answer on 5 and divide it by 2. Okay, so there's going to be half as many possibilities if I'm only using 5, lining up 5 kids. Or another way to do it, and on this particular problem it wouldn't be helpful, but I could cancel out the 2 times 1 on top and bottom. So I could also just do 7 times 6 times 5 times, whoops. You guys didn't tell me I forgot my 4. All right, anyways, we can do 7 all the way down to 3. Just multiply those together. That'd be a lot more work since we already did 7 factorial earlier. We can just do that divided by 2. Okay, sometimes this trick helps a lot though. Just cancel out the top and the bottom part that's the same, and that makes for a smaller problem. You'll see that on some examples probably. Okay, jumping into number 9. So going back to the problems. We are not solving number 9. We're just supposed to write the permutation symbols to say how we would represent that problem. So number 9, it says there's 7 different books to arrange in order on the shelf. That's pretty much the exact thing I was talking about. So you can assume we're putting all 7 books on a shelf. So out of the 7 books, we're choosing 7 to line up, and that's how we'd represent it. Okay, number 9, they're not asking us to solve it. If we did, it would just be 7 factorial, answer to number 5. But they're not saying solve it. We're just writing that. So number 9 is just that, and that's the end. Okay, number 11 is a little bit different. It says 14 objects are placed in 10 compartments. So out of the 14, we're only going to choose 10 of them to put in the compartments. So that's how we would write it. So again, we're not working it out yet. If I were to work it out, it would have been 14 factorial over 14 minus 10, 4 factorial. Okay? So, anyway. And then you'd have to work all that out. Most of these problems don't have gigantic. 14 factorial is huge, so they're nice to us most of the time on these, and we can use our answers on like number 7 to help us out. Okay, anyway, that's 11. 13 says using digits 7, 3, 9, 4, and 5. So how many digits different digits do we have to choose from? 5. And we're making a 5-digit number. So we're going to have to use all 5 of those digits. So that's 5, choose 5. So there's no repeats, so we have to use 1 digit in each spot. If there were repeats, that'd make it a lot more complicated. Number 15, something we're not ready for. Okay, so that's the last problem on the last section. 15 is on the new section. 15 is kind of we're going to start the same, but we actually have to solve it. So I'm going to go ahead and write it down, the permutation notation, and then show what it is as factorials and work it out. So on 15 it says, how many ways can 5 different books be arranged on a shelf? Kind of the same as number 9, right? So it's 5 books, we're going to arrange all 5. So how can we do that? So you put 5 factorial on top, this first number, how many are in the total group, over 5 minus 5 factorial on the bottom. So you subtract. Okay, 5 minus 5 is 0. 0 factorial is 1, which makes the denominator inconsequential. So really the problem is 5 factorial. Did we do 5 factorial? Well, I think my first example was 5 factorial. 5 times 4 times 3 times 2 times 1 was 120. So that's number 15. 120 is the final answer. Okay, 17 fit down here. We'll see. I think I can get it in there. All right, 17. Okay, this one's weird because they just say permutation straight out. So it's 7 objects, 5 are being arranged. So out of the 7, we're choosing 5. So it would look like. All right, so what goes on top? If you said 7 factorial, you are correct. What goes on bottom? That would be 7 minus 5, or jump ahead, 2 factorial. Okay, this was one of my examples, wasn't it? 7 factorial divided by 2 factorial. So number 5 was 7 factorial, which we got 5,040. I'm going to cheat a little bit. And 2 factorial, 2 times 1 is 2. So that's probably the easiest way to do this one is 5,040 divided by 2. 50 divided by 2 is 25. 40 divided by 2 is 20. So it's 2,520. All right, that's kind of a coincidence that was the example I made up. All right, number 19. Oh, that's a huge one. 19 is a huge number. I wouldn't be offended if you used a calculator on this, but since I'm doing it, you don't have to worry about it. 20, all the evens are, like the biggest even is less than 3,000. So there's nothing huge going on outside of 19. 19's huge. All right. Okay, 19 says, how many different arrangements are there of 10 children lining up for recess? Okay, so how many are in the total group? 10. How many are we going to choose? 10. Nobody's sitting out. Everybody's lining up. So it's just 10 factorial. Okay? Hopefully you guys kind of see the pattern. It's 10 factorial over 10 minus 10 factorial, which is basically nothing. So it's just 10 factorial. It's pretty straightforward. The biggest one that we have done is 8 factorial on number 7, which was 40,320. I'll go ahead and write out. Does that all fit on your screen there? So that's what we're going to do. We've already done 8 all the way down to 1 on number 7, which we got 40,320. So really, this is what's left. And we do need, so does order of multiplication matter? No. So the 10 is going to be pretty easy. I could just put 10 times that. I would just add another 0. So, and then don't forget, we still need to multiply by 9. Okay, that is it. That's a big one. So 3 million, blah, blah, blah. See how quickly, that's just 10 factorial and you're already up in the millions. So you can see how big these numbers get. So remember I said lining all 17 of you in your class, or 8, can't remember how many are in your class. That would be much more than millions. Would it be billions? I don't know. Lots of options up. So that's the last odd. And that will be it for this assignment. So hopefully you guys got that. If you have any questions, feel free to email me, and good luck.